There's an ocean on a moon 628 million kilometers from Earth. It has never seen sunlight. It has never felt warmth from a star. It has been sealed under 30 kilometers of solid ice for billions of years, completely cut off from the universe above it. And it might not be empty. For decades, Europa sat quietly in Jupiter's shadow, written off as a frozen oddity. Smooth. White. Boring. Scientists noted it the way you note a footnote, technically interesting, practically forgettable. The kind of world that fills a slide in a lecture and gets skipped over. But Europa was hiding something. Not just water. Not just ice. Something far more unsettling, a complete, chemically active ocean larger than every ocean on Earth combined, churning in permanent darkness, powered by the gravitational grip of the biggest planet in the solar system. And in September 2023, the James Webb Space Telescope pointed its instruments at this frozen moon and read something off its surface that stopped planetary scientists cold. Carbon. Organic carbon. Coming from below. This is the story of what Webb found, what it means, and why one icy moon might be the most important place in the solar system. The moon we thought we knew. Let's go back to 1610. Galileo points his telescope at Jupiter and notices 4 small points of light orbiting it in perfect, predictable patterns. He just discovered the Galilean moons, Io, Europa, Ganymede, Callisto, and in doing so handed humanity its first real proof that not everything in the cosmos revolves around Earth. Europa was the quiet one. Slightly smaller than our own moon, about 3,100 kilometers across. From a distance, it looks like a cracked egg, a smooth white sphere laced with reddish-brown streaks, ridges, and fractures stretching for thousands of kilometers in every direction. No craters to speak of. No towering mountains. No atmosphere worth mentioning. Just ice, scarred and resealed, over and over again. For most of the 20th century, Europa was a footnote. Mars had the volcanoes and the ancient riverbeds. Titan had the orange haze and methane lakes. Even Io, Europa's closest neighbor, was stealing the show with its continuous volcanic eruptions. Europa just sat there, frozen and unremarkable, reflecting sunlight back at us like a mirror that refused to show us anything useful. Then came NASA's Galileo spacecraft in the late 1990s, and everything changed. As Galileo swept past Europa, its instruments detected something strange in Jupiter's magnetic field, a disruption, a ripple that shouldn't be there. The only thing that could produce that kind of disturbance was a large body of electrically conductive liquid beneath the surface. Salt water. An enormous amount of it, churning beneath the ice, generating its own weak magnetic signature. The conclusion was stunning. Europa had a global subsurface ocean. Sealed beneath an ice shell estimated at 10 to 30 kilometers thick, there was more liquid water than all of Earth's oceans combined, wrapped inside a moon smaller than ours. That single discovery rewrote Europa's status overnight. Suddenly it wasn't a frozen nobody. It was the most water-rich body we had ever found beyond Earth. But knowing the ocean existed and being able to study it were two entirely different problems. The ice was in the way. Galileo couldn't drill through it. No instrument we had could taste what was underneath or measure whether anything happening down there actually mattered to biology. For the next 20 years, we pressed our faces against frosted glass. Europa knew we were out there. It just wasn't ready to talk yet. What Webb actually saw. In September 2023, 2 independent research teams published back-to-back studies in the journal Science. Both teams had been using the James Webb Space Telescope's near-infrared spectrograph, an instrument capable of identifying specific molecules on a surface more than 600 million kilometers away by reading the precise wavelengths of light they absorb and reflect. They were hunting for carbon dioxide. Not because carbon dioxide is inherently exciting, but because of where it came from. Carbon dioxide on Europa's surface has 2 possible origins. It could arrive from outside, delivered by meteorite impacts or deposited by radiation processing of surface materials. If that's the case, it tells us nothing meaningful about what's underneath. Or it could come from inside, from the ocean itself, dissolved in the water, carried upward through cracks and fractures in the ice by geological processes and deposited on the surface. If it came from below, it meant the ocean contained carbon. And carbon is the backbone of every known form of life in the universe. Both teams found it. Not scattered randomly across the surface the way external delivery would predict, but concentrated, densely and specifically, in a region called Terra Regio. Terra Regio sits on Europa's trailing hemisphere, the side that faces backward as the Moon orbits Jupiter. It's a geologically young region, meaning its surface has been recently reworked. The ice there is jumbled, fractured, and disrupted. Textbook evidence of material rising from below, destabilizing the surface, and refreezing in chaotic patterns. The carbon dioxide wasn't arriving from space. It was welling up from the ocean. Geronimo Villanueva, lead author of one of the studies and a planetary scientist at NASA's Goddard Space Flight Center, was direct about what the data showed. The distribution, the concentration, the geological context, all of it pointed inward, not outward. The ocean beneath Europa's ice contains dissolved carbon, and the geological churning of Terra Regio had carried traces of it upward like ink bleeding through paper. But Webb wasn't done. The same spectral data revealed something else mixed in with the carbon dioxide, sodium chloride and magnesium sulfate. Table salt and Epsom salt. The exact types of minerals dissolved in Earth's own oceans. Suggesting Europa's ocean isn't just wet, it's chemically complex, mineral-rich, and actively communicating with the surface above it. The ocean had finally started talking. The engine beneath the ice. Here's the problem that has to be explained before any of this makes sense. Europa is 628 million kilometers from the Sun. At that distance, solar heating is essentially irrelevant. The surface sits at around -160 degrees Celsius. By every physical rule we understand, this moon should be frozen solid from the surface all the way to its core. So why isn't it? The answer is Jupiter. And it's one of the most counterintuitive energy sources in the solar system. Europa's orbit around Jupiter isn't perfectly circular. It's slightly elliptical, stretched into an oval by the gravitational competition between Jupiter and the other large Galilean moons, particularly Io and Ganymede. This means Europa spends part of its orbit closer to Jupiter and part of it farther away. And as it moves, Jupiter's gravitational pull changes in intensity, constantly squeezing and stretching the moon's interior. This is tidal heating. The same basic mechanism that makes Io. Europa's inner neighbor, the most volcanically active body in the solar system. On Europa, the effect is subtler, but over billions of years it has been powerful enough to keep an ocean liquid beneath all that ice. Picture flexing a rubber ball rapidly between your palms. The ball gets warm. Now scale that up. The ball is 3,100 kilometers across and the force flexing it belongs to the largest planet in our solar system, a world more than 1,300 times the volume of Earth. The heat generated by that constant internal friction doesn't just maintain liquid water, it may be driving hydrothermal activity on the ocean floor. Hot vents where mineral-rich water meets cold ocean, where chemical reactions happen continuously, fueled by the heat bleeding up from below. This matters enormously because on Earth, hydrothermal vents are where life almost certainly began. Dark, pressurized, chemically rich environments at the bottom of the deep ocean, no sunlight required, no photosynthesis, just raw chemistry powered by heat. Entire ecosystems exist there right now, clustered around vents at the bottom of the Pacific, surviving on chemical energy alone. Europa's ocean floor. Sitting beneath 60 to 150 kilometers of liquid water, in direct contact with a rocky, silicate seafloor, could be doing exactly the same thing. Liquid water. Internal heat. Carbon. Mineral salts. Billions of years of geological time. That's not a dead ocean. That's a recipe. What comes next? Webb opened the door. Now something else is walking through it. NASA's Europa Clipper launched in October 2024, carrying the most sophisticated instrument suite ever sent to the outer solar system. It won't reach Jupiter until 2030, but when it does, the mission it carries has been sharpened by everything Webb revealed. Clipper won't orbit Europa. It can't. Jupiter's radiation belt hammers the Moon's surface with roughly 540 rem per day. Enough to kill an unprotected human in hours, enough to destroy spacecraft electronics in weeks if they stayed too long. Instead, Clipper will execute approximately 50 close flybys, some passing within just 25 kilometers of the surface, dipping in and retreating before the radiation can accumulate to lethal levels for its instruments. During those passes, 9 specialized instruments will go to work simultaneously. One of the most remarkable is SUDA, the Surface Dust Analyzer. Its job is to catch individual microscopic grains of ice and dust kicked off Europa's surface by micrometeorite impacts or plume eruptions, and analyze their molecular composition in real time. Each grain is a tiny frozen sample of whatever sits on or just beneath the surface. SUDA doesn't need a dramatic volcanic eruption to collect useful data. Even the faint background spray of particles constantly drifting off the surface is enough. One grain, analyzed correctly, could carry direct molecular evidence of what's in the ocean below. Another instrument, REASON, an ice-penetrating radar, will map the internal structure of the ice shell down to depths of 30 kilometers. Theoretical models have long predicted the existence of liquid water pockets trapped within the ice itself, isolated reservoirs sandwiched between the frozen surface and the deep ocean. If they exist, REASON should see them as bright radar reflections at shallow depths. Accessible water, much closer to the surface than the main ocean, could dramatically change the timeline for future lander missions. And Webb's carbon dioxide discovery has already done something invaluable for all of this. It drew a target on the map. Terra Regio, the region where ocean chemistry is visibly bleeding through to the surface, is now a priority site for every flyby that can be routed over it. The ocean has been signaling. We finally have the instruments sophisticated enough to signal back. Whatever Clipper finds in 2030, one thing is already certain: we are no longer guessing about Europa. We are investigating it. And somewhere beneath 30 kilometers of ice, in an ocean that has never seen a single ray of sunlight, the most important answer in human history might already be waiting. We just have to be patient enough and curious enough to go and find it. If this kind of storytelling lights something up in you the way it does for me, hit subscribe and come along for the ride. There's so much more of the universe left to explore, and we're just getting started.